Hello viewers, welcome back to Math in Motion, second annual review math tutor. As I said before, this time around we're going to be very diverse. We're going to be talking about economics, we're going to be talking some mathematics, we're going to be talking some statistics as we go ahead. Remember, as I promised last time that we shall going to be going through the growth theories. Today, we're going to talk about the Solow's model. Under Solow's model, we're going to prove that this equation, I want us to derive this equation, which is the Solow's model, which explains how development comes about. But before we go ahead, as we did last time, let us first talk about the assumptions of the model. From this Solow's model, I think is a continuation of the Haldoma equation, just modified. Solow just modified the Haldoma equation into his Solow equation, where he also, as we're going to see it, but he made the following assumptions. Number one, he said that labor force growth rate is a constant n, as we're going to apply it in order for us to prove this equation. He also said that the production function, if function of capital and labor is a factor substitutable, therefore here we can substitute labor for capital because as we see in Solow's as we saw in the Haldoma equation or model, so that factor inputs are non-substitutes, they are just complements. But now here, these factor inputs are substitutes. This means that this production function under Solow's model follows the Douglas equation, where shall have a continuous concave, it is a convex isoquant. Shall have a convex isoquant, shall have capital, labor, and then our isoquant is going to be convex in nature, showing that it is substitutable. In order for you to increase capital, you have to reduce some units of labor, and like the vice versa. Also, he also assumed that saving equals to investment, as we saw in Solow's model. And then he said also the saving rate is a constant function of total income, as we said that saving equals the saving rate times output. Like you save a fraction of what you earn. Then he said that production function exhibits a constant change to scale, that if you increase inputs by certain proportion, say 70%, also output will increase by 70%. I think these terms are not new to us, as you have been using them in the previous videos. And then he said here the difference between the Solow's model and the Haldoma model is here. Technological progress is given as a determined. This means that technological progress is not fixed, keeps on changing, but we saw in the Haldoma equation that the technological progress was constant. Remember, without wasting any time, let us go and see how we can do this in the shortest time possible. Now, as I said that this equation here exhibits, like, for it exhibits, here it is further substitutable, means that it has a convex isoquant, which means that here now we shall be employing, here we're going to employ a Douglas equation, and we're going to enjoy it as we go ahead. Now from there, members, I'm saying that let us now prove the Solow's model with ease. Now from here, we are saying that under Solow's model, we are saying that our output is a function of capital and labor, but now here we are saying that AL, where K is capital, A is our technology, and labor is, and L is our labor. Here I talk about technology affecting only labor. Technology does not affect capital. Therefore, technology improves labor productivity, not capital. And then, as we are saying that it follows a Douglas equation, therefore our output is going to be K power alpha, then A minus L power 1 minus alpha, which is our Douglas equation as per Solow's model. Now, from this step here, in order for us we're going to now, from this step, we have to divide through by AL everywhere, where AL is called effective labor. AL is effective labor. Now, we divide through by AL both sides. If I divide through by AL both sides, I'll have something like Y over T is going to be output by effective labor. I'm going to denote it as Y, small y. Y T over AL is output by effective labor, small y. Now here I'm seeing that this AL is going to die out and remain down, and then I will have only AL minus 1, which is down here. Therefore, I will remain with something like K over AL everything power alpha. And then here I'm going to be left with capital K over A, it is capital per effective labor, which I'm going to denote as small k. Therefore, I'm going to have my equation like small y, which is a function of small k power alpha. This equation here, it is talking about output by effective labor, capital by effective labor. Therefore, output by effective labor is a function of capital by effective labor. And therefore, I can simply write it that output by effective labor is a function of capital by effective labor. And then this is the equation I will want to use. I think that we are on that step. Now, members, from there, like from here, I can easily sketch my function. I say that if I want to sketch on a graph, I'll have my work as here. If I have here output by effective labor, here I have capital by effective labor. My question is going to be if k is 0, y is going to be 0, and then it's going to be it's going to exhibit diminishing returns. That output is going to increase by reaching maximum and then starts to decrease as capital becomes more and more. Output will reach maximum and then start decreasing. Then this is our f. This is our f of small k. This small k, which is our output by effective labor. Members, let us go ahead and now introduce another term. But remember, we said for a closed economy, remember this is just the continuation of the Harold-Goma equation. Now shall we say for a closed economy, what happens when you close the economy? We say that output, yt is a function of consumption plus investment. But remember, as we say that consumption and investment, but now here we're just interested in effective labor. We divide it through, next step we divide it through by AL both sides, and then AL here. What are we going to have? We shall have now YT over AL. We say we called it output by effective. Here they say this is output by effective worker by effective labor. Therefore, here shall have output by effective labor equals to now C over AL shall hold small c, which means consumption by effective labor, and then I over AL shall hold small I, naming it investment by effective labor. Small c, I'm saying small c is called consumption by effective worker. And then small I is called investment by effective worker. Or labor. Now from there, members, let us go ahead and say that. But remember, our investment equals to saving, as we said, and saving equals to small s yt. Small s, which is our saving rate. Now if we divide through everywhere by AL, divide AL everywhere, therefore I have something like small s, which is this one. Now small s divided by AA is going to be y over AA, we call it effective worker, which is going to be small y. Like I have now SY. Therefore, my savings rate, now this becomes that this is I equals to saving by effective worker equals to small s, which is saving rate times y. Then this is going to be my equation 2. Remember, I think we are together. I'm saying investment by effective worker equals to saving by effective worker, which is the same as having the saving rate times the function y. But y, remember, y is a function of small k, which is a function of effective by small capital by effective worker. Therefore, I equals S f of small k. F of small k is the y, which is that one. Therefore, from there, members, I think I can press them into this equation. Then shall have our y. Remember, shall say from small y equals to c plus I, but small a, this is function of small k, equals to c plus now I, which is sf of k, something like that. We are together, I think. Last step, we are together. Therefore, if I want to have now c, if I make this, c is going to be the same as having, if this one have small f of small k minus s f of k, and then c is going to be the same as having 1 minus s f of small k. and then this is what we call the go. That's an equation that we shall be interested in. But then, what do we need? I've expressed everything in terms of I have these equations, and then this equation of mine, I'm going to call it. This is what we call the gross investment. Yes, so gross consumption. Now, members, let us go ahead and now prove want reach here. Now, but now from that step, what are we going to do? Now here I'm seeing that if I try to sketch, here, remember here I have Y, income per effective worker, sorry, output by effective worker. Here I have small k, which is capital per effective worker. We say that our function is f, okay, this is called Y equals small f of k, which is our output by effective worker. But now if I introduce in saving, the saving part is this one. Saving part, this I, the saving part, which is the same as having a small f of s. Therefore, this is a saving function. Y equals to s. Sorry, this is the same. S f of k. But remember, this saving rate, this s is always small. It's between 0 and 1. Therefore, it is between 0 and 1. Therefore, it can't be more than this f of k. And therefore, the whole of this from here to here is our y, which is our income, output y. But then from here to here, and then from here to here, now this is our saving. Can call it I or S, saving, and then this is going to be our consumption C up here. I think by that we shall be able to interpret and then comprehend everything. Now, members, allow me to take you now on how we are going to reach this step here. We have two important questions now. We have question 1 and then question 2. Then let us go ahead and now see how we are going to go and have this equation here up. Yes, let me put off this again to have space. I think you have been following. And pause the video and then you copy and then as we go ahead. Now, members, from there, but remember we said capital accumulation. Remember I said for capital accumulation, we say that this small k, capital per effective worker, equals to what? Capital K over AL. I think that together. Small k equals to capital K over AL. Capital per effective worker is this one. Now, here, I want to introduce natural logarithms on both sides. If I put natural logarithms here, this side I have ln small k equals the same, because this is a fraction. I have ln of now k minus ln of A minus ln of L. Now, from that step here, I differentiate with respect to t. Here I'm saying I differentiate as we did in the Solow's model. So as we did in the HD model, also here we differentiate. I said if I'm differentiating a natural log function, I differentiate the variable here and then divide by the original variable. Therefore, I'll have this small. Okay, I'll have something like this: the small k dt divided by small k. But now for us, we say that if we did our derivative, we're going to just call it small k star. If you simplify the star, I'm just getting now the derivative, the change. Therefore, from here, I can just write it as like this. Here I have small k dot over small k equals, again here I have capital K over capital K minus capital A dot over A, then minus capital A over L. But remember, now we argued that the growth rate of remember we call this in the Hardeman equation that this is the growth rate of capital, this is the growth rate of technology, and then this is the growth rate of labor. And therefore we say that the growth rate of labor is constant and it's going to be n. Then the growth rate of technology is going to be gn, and GA, that's called GA. And then now here we are going to have something that's going to be beautiful. Therefore, but remember, change in capital stock is the same as having, remember I had discussion from capital stock. Okay, let me take you through, let me take you again for what we did. Say that KT plus 1 equals to KT minus sigma KT plus I t. Now if I bring this kt this side, I have kt plus 1 minus kt equals it minus sigma kt. Something like that. Therefore, this is the change in capital stock we are looking at. This kt is the same as having it minus sigma kt. Therefore, this equation I'm interested in. Therefore, to save space, I just need to say that from changing capital stock, I said changing capital stock, but kt star equals to it minus sigma kt. Then I replace it here. Therefore, I have small kt, small k over small k equals to, now here I have, instead of having this one, I won't have this one, it minus sigma kt. Then I divide kt, I divide k everywhere. Therefore, I have this one over k. Then here the k will disappear. Then minus, instead of writing this, I want to write ga. And then instead of writing this, I want to write minus n. Numbers are we together? Now from here, at this step here, let us be serious, and then we see how this step comes in. At this step here, I'm going to, the step is going to be on it over k. I'm going to multiply AL and divide AL. Therefore, I'll have that nothing. Therefore, my next step is going to be that from here over this one equals to, now I have IT over AL times AL over K minus sigma minus GA minus N. I think I've done nothing. This is the same as this one. But now, what I want to bring in now is that, remember we said IT over AL is called investment by effective worker. Now we said KT over AL, it was capital per effective worker, but now it is now the receipt. Therefore, I'll have 1 over T. Therefore, to go ahead, I'll have something like now to go ahead from this step here, I'll have something like small k over small k equals to, now here I have my small I. Now for this I'll have 1 over k, 1 over small k. Now minus sigma minus dA. Okay, minus sigma plus dA plus n, but under bracket, just for this negative to be there. Now from here, I'm going to multiply small k everywhere. Then I'll have my small k equals to I minus sigma plus dA plus n, everything times small k. We have to remember small k, we called it as capital per effective worker. And then this is what this is now changing capital by effective worker. But in a steady state, say at steady state, this change in capital by effective worker is 0. Why? Remember, a steady state means that there is no change. Therefore, change in capital by effective worker is going to be 0 at steady state. Like in the long run equilibrium, at steady state, change in capital will be 0. Therefore, the unit will be stable. Therefore, there won't be any change. Therefore, if I say that at steady state, change is going to be 0. Therefore, I will have the whole equation equal to 0, and then I will have my I equals to sigma plus GA plus N, and then a function of K, small k like that. But remember, we say that I is the same as having Sy of K, but we say that, but remember our equation was saying that, but I equals to SF small k. Therefore, from there, and then this is the same as having small I, investment, the savings rate. Therefore, I will just say that this is the same as, so this is the same thing as having the savings by effective labor. Therefore, from here, I'll have that S f of k, small k, the same as having sigma plus dA plus n, a function of small k. And then this side here is called the break-even investment. Then this side here, it is the saving, it is I or S, investment by effective worker, and then or saving by investment, saving by effective worker. And then this forms our Solow's model. Also from here, we are seeing that in order for us to increase saving or investment, remember investment corresponds to output. because if you invest more, output will be more. They are saying that it is very crucial. We have three items here. We have, first of all, we have the depreciation rate, we have the level of technology, and then we have the population growth rate. Now, how do these three variables affect our output? As we see again that in order for us to increase output and in order for us to increase saving or investment, the depreciation rate must has to be as low as possible. If technology increases, our investment will increase and saving will increase likewise. And then N is the population growth rate. As N increases, savings will be low. And therefore, there's a negative relationship between savings and investment. Now, members, from there, I think we are able to appreciate this, but let me now show it graphically. Graphically, you are seeing that we have two things. We have investment, which is this one, and then we have also the break even investment. Let me call it investment, and then break even investment on the y-axis. Then here you have the capital per effective worker, small k. Now, if I want to sketch this, I have two equations that my saving rate, my investment rate is this one, as we did last time. It is S, a function of small k, because small k is this side. But now, if I have investment this side, and then I have small k this side, therefore this is just a linear equation. If you just call this is 3x, remember, now if I have something like y equals 3x, now what do you have? Just a straight line through x, through 3. Therefore, I just have something like, and then this is going to be my sigma plus GA plus N, a function of K, like that. And then this is the optimal capital, K star, that we require to have that investment. This is 0. And then this is the Solow's model. Just like that. Now from here, we are going to say that the whole of this is the investment. This is the investment. Now this here is the change in capital stock. We are talking about change in capital stock, and then this one is going to be our break-even investment, the sigma plus GA plus N, a function of K. That is going to be our thing. I think members have tried to explain. For any questions or any step you've not got well, try to reach me out on my number. As you see the video at the start, you also see my number or email, or anyhow you can get me. Members, thank you for watching. Solow is your math tutor. I'm always here to provide for everything that you need. As I said, this time around, we're going to be very diverse. Some economics, some mathematics, statistics, everything that you want. Remember, I think you have enjoyed this set of pieces I've given you. Thank you for watching. As I said in the last video, that we got 1,000 subscribers last time, but members, we still need to increase the number of watch hours. This calls for us to share the video to our friends, to always watch the videos and then comment, because I want to be engaged also. If you engage me, then I feel happy and I am able to push and still give you more content. Members, thank you for watching. Solow is your math tutor, and I think you have enjoyed. Now, see you in the next video when I'm doing the AK model, and I think that is it. Thank you.